Okay, in this video here, we're going to continue our study of related rates. And this time we have a ladder that's 25 feet long leaning against the wall of a house. So if here's my house, what's happening is I have a ladder here. And this ladder is 25 feet long. And the base of the ladder, so this point here is being pulled away at a rate of 2 feet per second. Well, if it's going to be pulled away here, how about we call this x here? So the wall is going to be perpendicular. And so then I know that this is going to be dx dt is 2 feet per second. Okay, I want to know how fast is the top moving down. So how fast is this moving downwards? So if I call this y, I'm looking to find dy dt. I don't know what it is when it's 7 feet from the wall. So when x equals 7 feet. Okay, so we've gotten the information that we know and what we're looking for in terms of math. And now we need to find a relationship that relates x, y, and 25 somehow. And because it's a right triangle, our most common relationship that exists is x squared Pythagorean theorem. And so I use Pythagorean theorem to relate the variables that I have information about. And I'm also recognizing that I need dx, I'm looking for dy dt. And I know dx dt, so the dt is on the bottom, so I know I'm going to have dx dt here. And I have a relationship between x and y. And so if I think about it, I could find dy dx. And so here's the chain rule. And this step here, even though it sounds so easy, is not easy to come up with. How do I use the chain rule? I have dy on top, dt in the bottom, dy on top. These will, in essence, cancel out. So I will have this to work with. So now I need to find dy dx. But my problem is, I don't have it in terms of y, so I have to manipulate this equation. I know that y squared is equal to 25 squared minus x squared. And then I know that y then is equal to 25 squared minus x squared, the square root of this, which is to the 1/2. Now here I can calculate dy dx. So dy dx is simply going to be the 1/2 comes down, 25 squared minus x squared to the negative 1/2, using the chain rule in this scenario, times a negative 2x. And so dy dt is what I'm looking for. I know dx dt is 2, and so if I put this together, I know that dy dt is equal to dy dx, which is 1/2, 25 squared minus x squared to the 1/2 minus 2x, times dx dt is 2. And we want to find this when x equals 7. X equals 7. So I plug my 7 in. I get 1/2, 25 squared minus 7 squared to the 1/2 times negative 2 times, oh, I lost my negative, don't forget the negative, negative 1/2 times 2, and this is 7 times 2. And when I do this whole calculation, and if I look at my notes, I can figure it all out. I know that it ends up being negative 7/12 feet per second. I just did this with my notes or the calculator. All right, so that was A part. All right, so in B part now, we have all this information. We know we have a wall. We know the ladder is coming out this way at 2 feet per second. And B part says find the rate at which the angle between the ladder and the wall of the house is changing. So between the ladder, here's the ladder, and the wall of the house is here. So we'll call this here theta. I want to find now d theta dt. I don't know what it is, but I want to do it again when the ladder is 7 feet from the wall. Okay, so I know the information I have and what I'm looking for. My next step is to look for a relationship that relates theta and x somehow. Well, theta is an angle, so I know trigonometry is coming my way, and so I know this is the opposite, this is the hypotenuse. So I know that the sine of theta is equal to x over 25. All right, and so now I have to think about the chain rule. I know that the chain rule, I'm looking for d theta dt. And if I just think blindly here, I have theta and x, I know that I can do d theta dx times dx dt. That's what d theta dt is equal to. Dx dt is 2, and now my scenario is I want to find d theta dx. But theta is inside of sine, so that could be tricky. What I could do, though, is if I rewrite this, I can say x is equal to 25 sine theta. I could find dx d theta. And if I find dx d theta, this is just the reciprocal of this. I flip it. So dx d theta is 25 cosine theta. And so if I want to find d theta dt, I'm going to get, well, 1 over d theta dx. I'm flipping it over, which I know is going to be, oh, I said that wrong. Let me try that again. 1 over dx d theta is what this will be. If I reciprocal the fraction, I end up with this. That's how I can flip it around. These are the same thing algebraically, times dx dt. Well, I know that's 1 over 25 cosine theta times dx dt, which was 2 if I recall correctly. And I want to find d theta dt. And I want to do this when x is equal to 7. My problem, though, is I have theta. I don't have x. So in order to get rid of it, I'm going to go back to my initial relationship, or maybe even to this relationship. And so I know that sine of theta is equal to x over 25 if I plug x in. And so theta then, using my calculator, if I go make sure I'm in radians, because this is calculus, sine of 7 divided by 25. So here is my angle, 0.284. And so then d theta dt is equal to 1 over 25 cosine 0.284 times 2, I'll put up top. And so if I go 2, divide by 25 cosine, I'll make sure this is all in the bottom, 25 cosine, my answer. I end up with d theta dt, so 0.0833 radians per second. And so the angle is changing, this angle is changing at 0.83 radians per second. So we have to be clever with our chain rule here. And this kind of relationship here, those kind of flips are really quite helpful at times. So recognize that if I do that, I know that d theta dx is equal to 1 over dx d theta. Because if I change this to multiplying, it flips the fraction. So these are equal, and that's a handy thing to hang on to.